Modernage MCQs Physics second year Unit 19 Atomic Physics Part 2. According to Bohr theory, electron revolves in allowed orbits with angular momentum. Option A, nh divided by 2 pi. Option B, 2nh divided by pi. Option C, 2 pi divided by nh. Option D, pi by 2nh. The key is nh divided by 2 pi. Therefore, the correct option is A. Reason: the angular momentum of electron in allowed orbits of atoms is quantized and given by nh divided by 2 pi. It is one of the postulates upon which the Bohr model of hydrogen atom is based. Hence, the angular momentum of electron is nh divided by 2 pi. What is the angular momentum of electron in the second orbit? Option A, h divided by 2 pi. Option B, h divided by pi. Option C, 2 pi divided by h. Option D, pi divided by 2h. The key is h divided by pi. Therefore, the correct option is B. Reason: the allowed orbits are quantized. For second orbit, the quantum number n is equal to 2. Therefore, the angular momentum is L is equal to nh divided by 2 pi is equal to 2h divided by 2 pi, which is equal to h divided by pi. Hence, the angular momentum in the second orbit is h divided by pi. What is the angular momentum of electron in the second orbit? Option A, 1 into 10 power minus 34 kilogram meter square per second. Option B, 2 into 10 power minus 34 kilogram meter square per second. Option C, 3 into 10 power minus 34 kilogram meter square per second. Option D, 4 into 10 power minus 34 kilograms meter square per second. The key is 2 into 10 power minus 34 kilogram meter square per second. Therefore, the correct option is B. Reason: the allowed orbits are quantized. For second orbit, the quantum number is L is equal to 2. Therefore, the angular momentum is L is equal to nh divided by 2 pi, or L is equal to 2h divided by 2 pi, which is equal to h by pi, which is equal to 6.63 into 10 power minus 34, which is the value of h, divided by 3.14, which is nearly equal to 2 into 10 power minus 34 kilogram meter square per second. Is the angular momentum in the second orbit is 2 into 10 power minus 34 kilogram meter square per second. The electron revolving in ground state radiates energy. Option A, minus 13.6 electron volts. Option B, minus 3.4 electron volts. Option C, minus 1.5 electron volts. Option D, 0 electron volts. The key is 0 electron volt. Therefore, the correct option is D. Reason: the ground state of an electron is a stable orbit. The electron in stable state does not radiate energy, which is basic postulate of Bohr atomic model. Hence, the energy radiated by an electron in ground state is 0 electron volt. An atom radiates energy when electron jumps from higher to lower stationary orbit. The magnitude of energy depends on option A, separation between the orbits. Option B, speed of the radiated photon. Option C, frequency of radiated photon. Option D, medium between the orbits. The key is frequency of radiated photon. Therefore, the correct option is C. Reason: according to basic postulate of Bohr theory, an atom radiates energy when electron drops from upper level to lower one. the energy radiated is equal to the difference in the energies of the orbits. The quantum of energy radiated is delta E is equal to En minus Ep, which is equal to Hf, where F is the frequency and H is the Planck constant. Hence, the energy of photon depends on the frequency. The speed of electron in nth state of hydrogen atom is given by the equation. Option A, En is equal to Nh divided by 2 pi m r n. Option B, En is equal to Nh divided by 2 pi m r n. Option C, En is equal to 2Nh divided by pi m. Option D, Vn is equal to 3 pi h divided by 2 nm. The key is Vn is equal to nh divided by 2 pi m or n. Therefore, the correct option is A. Reason: the angular momentum of electron in nth orbit m or n, Vn is equal to nh divided by 2 pi. Therefore, the speed of electron in nth orbit is Vn is equal to nh divided by 2 pi m or n. Dividing both sides of the equation by m or n, we get Vn is equal to nh divided by 2 pi m or n. Hence, the speed of electron in a state of hydrogen atom is Vn is equal to nh divided by 2 pi m or n. The radius of nth Boy's orbit is option A, Rn is equal to nh divided by 4 pi square k m e square. Option B, Rn is equal to n square h square divided by 4 pi square k m e square. Option C, Rn is equal to nh divided by 2 pi square k m e square. Option D, Rn is equal to n square h square divided by 2 pi square k m e square. The key is Rn is equal to n square h square divided by 4 pi square k m e square. Therefore, the correct option is B. Reason: the Coulomb's force exerted by the nucleus on an electron provides centripetal force. For hydrogen atom, the centripetal force is equal to the Coulomb force, or mvn square divided by n, which is the centripetal force, is equal to k e square divided by rn square, where k is the constant of proportionality and it is 9 into 10 power 9, or m into n h divided by 2 pi m or n whole square into 1 over r n is equal to k e square divided by r n square, or r n is equal to n square h square divided by 4 pi square k m e square. This result is given by the simplification. Hence, the radius of nth Boyle's atom is Rn is equal to n square h square divided by 4 pi square k m e square. The total energy of an electron in nth orbit of a hydrogen atom is option A, plus k e square divided by 2Rn. Option B, plus k e divided by 2 or n. Option C, minus k e square divided by 2 or n. Option D, minus k e divided by 2 or n. The key is minus k square divided by 2 or n. Therefore, the correct option is C. Reason: the total energy of electron in the nth orbit is En is equal to kinetic energy plus the potential energy, or En is equal to 1 by 2 mv square plus V into minus E, which is the potential energy, which is equal to k E divided by 2Rn minus Ke divided by Rn, which is the value of the potential wave into E, is equal to Ke squared divided by 2 or N minus Ke squared divided by Rn. Simplification gives En is equal to minus Ke squared divided by 2 or N. Hence, the total energy of an electron in nth orbit of hydrogen atom is minus Ke squared divided by 2 or N. What will be the energy of an electron in the first orbit of hydrogen atom? Option A, minus 13.6 electron volt. Option B, minus 3.6 electron volt. Option C, minus 1.5 electron volts. Option D, minus 0.85 electron volts. The key is minus 13.6 electron volts. Therefore, the correct option is A. Reason: the quantum number n is equal to 1 for first orbit and radius of first orbit is r1 is equal to 0.053 nanometer. Therefore, from En is equal to minus Ke squared divided by 2 or N, the energy of the first orbit is E1 is equal to minus Ke squared divided by 2 or 1, which is equal to minus 9 into 10 power 9, which is the value of K, into 1.6 into 10 power minus 19 whole square, where 1.6 into 10 power minus 19 is the charge of the electron, divided by 2 into 0.053 into 10 power minus 9, because 0.053 nanometer is equal to 0.053 into 10 power minus 9 meters, or E1 is equal to minus 217.04 into 10 power minus 20, which is equal to minus 217.04 into 10 power minus 20 joule divided by 1.6 into 10 power minus 19 joule, because 1 electron volt is equal to 1.6 into 10 power minus 19 joules, or E1 is equal to minus 13.6 electron volts. Hence, the energy of electron in the first orbit of hydrogen atom is minus 13.6 electron volts. Helium neon laser device is filled with option A 80% of neon, option B 15% of helium, option C 15% of neon, option D 85% of xenon. The key is 15% of neon. Therefore, the correct option is C. Reason: in helium neon laser device, neon is lasing gas and helium is present to shift the neon atoms to metastable state by coulomb. For maximum chance of coulomb of excited helium atoms with neon atoms, the device is filled with 80% of helium and 15% of neon gas. Hence, a helium neon laser device is filled with 15% of neon gas.